Hey everyone, we are the Team 4 and this is our recreation of the Marriotts bottle, where we only had to use recycled materials for the construction of it. According to the Rosiles law, when the water level drops, the hydrostatic pressure decreases, which causes the flow rate to slow down, but if you need a perfectly constant flow rate, that is where a clever device called the Marriott bottles come in. The objective of this experiment was to build a functional Marriott bottle using simple household items and analyze its flow rate. We used 1 liter plastic bottle, a plastic straw, bubble gum, and a nail. First, we used a hot nail to poke a small hole near to the bottom. Then we made a hole in the cape, inserted the straw, and sealed it up with a bubble gum. That bubble gum aerosol is the most critical part of the whole setup.
To test it, we filled the bottle with water and opened the bottom hole. We used a stopwatch to measure exactly how long it took to discharge 110 milliliters of water. To make sure our data was reliable, we repeated this process for a total of 5 trials. The results were incredibly consistent. We calculated the flow rate by dividing the volume by the time. The times only ranged from 78 to 89 seconds, giving us a stable average flow rate of 1.38 milliliters per second. To prove how consistent this was, we calculated the standard deviation for the flow rate, and it was a tiny 0.0182 milliliters per second. Also, we ran an error analysis, and our highest percentage error was only of 1.9%, and our lowest was just of 0.3%. We also graphed volume versus time, and the resulting linear regression had a highly linear positive trend. Because the slope of a volume versus time graph represents the flow rate, that perfectly linear trend physically proves that our Marriott bottle effectively eliminated the drop in hydrostatic pressure. In conclusion, this experiment successfully proves that as long as you have the right conditions, like a solid airtight seal, a constant flow can be achieved without any mechanical pumps. Thanks for watching.